Teresa's house.
And even in this configuration, though I can't control the Z motors independently, there are still firmware options that help you line that Z up if you need to. So for this first configuration, basically we're going to mirror what Prusa does. Now you don't need smart drivers necessarily. You can use anything without sensorless homing, but it is very useful to have something where you can adjust the cruise via the software. If you use something like an A498 or an 825, that can cause crashing when you really need to be kind of gentle when you're going to the top of your Z axis to get everything lined up. So I recommend using something like a 2208, 2209. There's a lot of different ones out there that you can control the current, but it can be done with the simple drivers. So just to show you here, I have only 4 drivers enabled. Remember, my Z motors are sharing the Z driver. We're going to enable them as 2208s. 2208 does not have sensorless homing. Then we're going to go to configuration _ADV.h, and we're going to enable mechanical gantry calibration. This is essentially the same thing that Prusa does. You can adjust the current with this feature for when it does that calibration. I usually run at 800, so I'm going to run at 400, that's half for the calibration. Extra Z height, so when you set your height of the printer in the normal configuration, mine is set at 200, that gives the maximum that it's going to travel to do this calibration, and then this is the amount that it does over that. So it just does it for 15 more millimeters to make sure everything is nice and flat at the top. It's all the way up on both of those holders. This is what it does, so you don't have to have sensorless homing. And then you can set the feed rate that it uses to move during the calibration. You can also flip it if you have a printer that needs to do this in the minimum direction instead of max. If you have a setup where it will be aligned that way, you can flip it around. You can adjust the safe position, so when it does this calibration, if you needed to move your nozzle out of the way for some reason, you can do that here. You can adjust the part feed rate, so when it's done with the calibration, how fast does it return to home or wherever it's going to go. You can set pre-calibration commands if you wish, and post-calibration commands. And by default, G28, just to home it again. I leave that in there because it's nice to have it bring it all the way back down to 0, so you're ready to start printing. So we'll enable this, and we'll go ahead and flash it to the printer. And then all you need to do to run that process is enter a G34, and that's going to start bringing that gantry all the way to the top. And just like the Prusa configuration, the printer's going to home, then it's going to take the Z all the way to the top. It's going to bottom out on these 2 top brackets, and then bring it all the way back down to home. So this process is going to get your gantry leveled out by squaring it with the top of the frame. And that's going to be pretty useful if you're powering it off and powering it on, because you could actually lose some steps by the gantry falling a bit. But these machines also have motor current timeout. So your motors don't stay energized all the time. So when that happens, you could still lose a couple of steps, because you can backfeed these lead screws. And you don't want to have to do that level process every time you print. But there's a setting to help with that as well. And that can be adjusted in configuration _ADV.h in Marlin in idle stepper shutdown. So by default, deactivate time is 120 seconds. And for most motors, that's going to be fine. But to keep it from falling, in the Z, you can set this one to false, which I've done here. And if you have a smart driver, this idle current can be brought down quite a bit. In the has trinamic configuration, the first line here is hold multiplier. I set mine to 0.3, so it's going to hold it at 30% of current of what it normally would be. My Z current is currently set to 800. So after that setting's enabled, after you've moved your Z once after first boot up, then you will never lose that holding current. They'll always have just a little bit to keep it from falling and rooting the next print if you're a person that doesn't shut the printer off from use to use. So that can help you keep Z synchronized. So that is a really nice feature, being able to level up on here. And you don't have to have the most smart driver. You can do it with a 2208. You don't necessarily have to have sensorless homing. And you don't have to have a Z probe to use it. But what if your printer is like mine here? Log isn't necessarily all that square. I did cut the frame out of a piece of wood. These 2 holders might not be the same distance as each other, so you can't level very well across the gantry. Well, if you do have a Z probe, there's a way around this. And for this next scenario, you will need 2 Z drivers. So we're going to use one in Z and one in E1. And this is pretty much the biggest question that I get. How do I set up this configuration to work correctly? And they will work independently, so we can use this feature that I'm getting ready to show you. So let's get all that set up now. So this is the configuration that we're going to use for this setup. It is again a 1.3 board. We're going to use separate drivers on separate Z motors. And just play like all these drivers are all the same type. This one's actually a 2209 and these are 2130s. But you don't need centralist homing for this configuration. You can use a 2208, but again, recommend something that you can set the current on the fly no matter what it is. But you can do that on a lot of drivers. They don't necessarily have to have stall guard or all the fancy things Trinamics have. But we're gonna have one Z motor plugged in here for Z, and the other one is gonna be plugged in to E1. Separate drivers, we can control them separately. Also, just note that it doesn't matter which motor goes where. It doesn't matter if you use the left or right Z on Z or E1. You can flip them around, it's not gonna care. Now back to Marlin, configuration.h. You can select whichever driver you have here, but we're going to use all 2209s. Again, centralist homing doesn't matter. But we've got 4, X, Y, Z, and E0, and then we're going to use that other extruder driver for Z2. So you don't want to use it on E1 down here, you want to actually call it Z2, what we're going to use it as. So that will enable the 5th driver. Now we need to set up the configuration, so configuration_adv.h. We are going to comment out the mechanical gantry calibration that we showed earlier, because you can't use this method and this one on the same machine. You have to pick one or the other. And then at the top of the file, there's a whole section about dual steppers, dual end stops. You can use them on X, Y, or Z. And we are going to uncomment the section for multiple Z drivers, and then we're going to set it to 2. This is automatically going to select that E1 driver. You can change that up in your pins file if you wish, but this is also the section where you would set up multiple end stops. So if you take the comment off of this line right here, you can set up that same scenario that the Anycubic printer has. And just to show it one more time, that's the scenario where we have multiple end stops. We've got one over here, and then one over on this side. When it homes, it hits them both, waits for them to trigger, and then it knows that the gantry is level if those end stops are level. Not every configuration is going to work like that, but this is where we'd set that up. And by default on these boards, it's going to call X max for that second end stop if you would like. Now, we usually use this for like filament detect, these pins right here, but the configuration of Marlin is going to default to these pins most of the time. So that's where you would plug in your second end stop. First one, second one. Again, it doesn't matter which one is which side goes to which end stop, but I would pair them up with the motor cable, left and right, just to make sure you don't get confused. It's just easier to figure things out that way. So that's how you use multiple end stops. We're not going to do that in this video, but it's there if you need it. So we're just going for 2 motor drivers, 2 motors, so they're independent. But then we're going to jump to Z-Stepper's Auto Align. This is the feature that can help you out with this. We'll just take the comment off of Z-Stepper's Auto Align, and then it gives you an explanation of what it's going to do. You can use multiple Z motors, 2, 3, or 4, to achieve the same thing. RepRap firmware does this as well.
This way.
I can't go that way.
Buzz this way.
I can't go that way. It doesn't go out.
This way.
Down here on Z-Stepper Align X and Y, you can set the points where you would do this alignment at. On this Mark 42 bed, I do have specific probe points, so I have set their location. This is the first probe point, 27107. This is the second probe point, 229.5, 107. You'll see that on the bed here in a moment when we run it. But then it's going to give you a little map of the orientation of where it's going to take those probes, depending on what setting you select. We are going to run in the 0 position with 2 steppers, so that's 1 and 2, left and right. That is set right here. If you'd like to use other spots, you just change this number according to your map. And you can get pretty involved with one of these if you have multiple stepper motors. This down here requires 3 motors, but now you're getting closer to that true level like Rec Wrap does. You can actually adjust the tilt of the bed before you even build a mesh grid, which is pretty accurate.